Welcome to Spring LIB.
Here we've just got a lot of structures to get through where we will be discussing lone pairs, bond angles and structures for all of these examples. Now I've drawn them out already to save us time. So let's start off with our top left here. So we have SO2 and then our bond angle here is approximately 104.5. Now we have a bent structure here. Sulfur is in group 6 and so we have one lone pair. And then moving on to our next example here, we've got SO3. Now we have no charges, so we've got all of our double bonds present. And we have bond angle of approximately 120 degrees and a trigonal planar structure. And now moving on to this example here on the far right. So we have 4 substituents and so we will have a tetrahedral conformation and our bond angles will be approximately 109.5, where we have two negative charge present here, 2 on oxygen, where if we were to throw in this electron pair, we would knock up this electron pair onto that oxygen and we would always have 2 negative charges present in the molecule. Now you could also do the same with the sulfur atom because we have 3 lone pairs there. So now moving on to our next example. So in terms of structure, we have a general tetrahedral structures that will be adopted by each of the SO4 molecules. However, they're joined together and so we will see bond angle of approximately 104.5 in here. And then our bond angles in our tetrahedral are approximately 109.5. And that's between these bonds here. So now we've got an actual tetrahedral structure drawn out. We've got SO4. So this is exactly how these components would look in this compound. We have our bond angles of 109.5 again. And then we have lone pairs present, so we can delocalize some of this negative charge and move about our double bonds and charges. Next, we've got a trigonal planar again, where we've got our bond angles of approximately 120 degrees. And now lastly, we're looking at our sulfur fluoride molecules. We've got 3 of them here. So firstly, we have our octahedral, where we have bond angles of approximately 90 degrees here. We have no lone pairs because sulfur is in group 6 and it has 6 single bonds. So all of our electrons in our outer shell of sulfur are being used. Next, we have this seesaw structure where we have an angle of 180 degrees here. And then we have an angle of approximately 120 between our equatorial fluorines. Then we have one lone pair there. And then lastly, we have a bond angle of approximately 104.5. This is very similar to water. H2O is a bent structure as well because sulfur and oxygen are in the same group. They both have 2 lone pairs, so you're going to get the same degree of bend within the molecule. And that completes all of our structures in terms of naming the structure geometry as well as bond angles.